What happens if we put Earth in a microwave? Imagine the most reckless kitchen stunt in history. Someone shoves the entire planet into a microwave and hits start. Absurd? Absolutely. But let's treat it as a serious thought experiment. First, a quick refresher. Microwaves are electromagnetic waves at about 2.45 gigahertz, wavelength roughly 4.72 inches. It's not magic, it's physics. Electric fields make water molecules, and a few other polar ingredients, swing back and forth. Molecular level friction becomes heat. In your kitchen, that warms soup. On a planetary scale, the thing we have most at the surface starts to boil. The oceans. A regular microwave oven is about 1 kilowatt. For a planet, that's nothing. Earth wouldn't even notice. So in our experiment, we scale the power to match the size. Instead of 1 kilowatt under a soup bowl, we fire up 960 quintillion kilowatts. That's roughly 960 quintillion household microwaves running at once. Now the movie really starts. There's a catch the brochures don't mention. Microwaves don't penetrate water well, especially salt water. This isn't through and through heating. They reach only a fraction of an inch to about an inch deep. The result? Ocean surfaces heat violently and flash to steam. Right above the waterline, it becomes blisteringly hot. Steam piles up at the surface and forms a dense, incredibly hot fog. Stand on a beach and you won't last long. Air itself heats poorly in microwaves, but air loaded with water vapor heats just fine. That hot, humid air surges inland. Coasts take a double hit, intense radiant heat from above, and from the sea, giant waves driven by hurricane-force winds. The huge temperature contrast between air right at the surface and the air above creates large pressure differences, and that spawns very strong winds. First to go are the wet places: oceans, lakes, marshes, waterlogged soils. On land, rainforests turn into steam rooms, while dry deserts? Surprise! Heat more slowly at first because there's almost no moisture to absorb energy. But the relief is brief. The tsunami of vapor from the oceans turns even the Sahara into a sauna. The atmosphere gets a massive shot of water vapor. Pressure rises. Enormous clouds build. We get the storms to end all storms. Lightning strikes any protruding object, from skyscrapers to lone trees. If you ever wanted to photograph lightning, this would be the moment. What about people? Skin contains water. Muscles are largely water and electrolytes. Microwaves penetrate a few centimeters, so they heat the body very efficiently. Exposed eyes fail first, then skin, then muscle. Hyperthermia and heat stroke follow, along with burns to the airways from superheated steam. On a global scale, survivors are those who can shield themselves from the field. Metal Faraday cages, caves deep in rock, and above all, deep water. Microwaves penetrate salt water poorly, so dozens of feet below the surface is relatively safe, at least until it too heats up. Rocks aren't ideal microwave targets, but they have pores and bound water. When microwaves hit moist minerals, they can cause micro-explosions. Localized steam blows apart the structure, creating cracks. Volcanoes, however, won't put on a fireworks show. Microwaves won't switch them on. Earth's oceans hold about 352 quintillion gallons of water. That's 352 with 18 zeros after it. With our souped-up microwave pushing about 960 quintillion kilowatts, the oceans need about an hour to go from room temperature to steam. Water vapor is the most powerful natural greenhouse gas. Pump it into the air in colossal amounts and Earth gets a steam blanket. As if you wrapped the whole planet in insulation, only this blanket is boiling. In the gas phase, water occupies far more volume than as a liquid. Evaporate the oceans and surface pressure soars to around 3,700 pounds per square inch. For comparison, it's about 15 pounds per square inch today. Above 3,200 pounds per square inch and a temperature of 705 degrees Fahrenheit, water becomes supercritical. You can't say, this is vapor or this is liquid. You have a single phase with traits of both: density like a liquid, expansion, and flow like a gas. Supercritical water is far denser than ordinary steam, yet fills space like a gas. What happens when we turn the microwave off? An Earth covered in supercritical water wouldn't have oceans or shorelines. A dense, hot fluid blankets the surface, with a towering steam atmosphere and a thick cloud deck above. From orbit, you wouldn't see continents, just a bright, milky white sphere. The only real chances of survival lie with microorganisms deep within rock. sealed off from the outside world. Do not try this at home. Don't forget to leave a like and hit subscribe so you don't miss the next video.